vein are things to deal with small machines. And to start with, I'm going to talk about a little project that I'm working right now as part of a product called picoDB, which is a database tool which does not use SQL and is based on eLua. So the agenda for this talk is, well, why did I get into this project to begin with? Why picoDB? And we'll give you after that an overview of kind of the overall structure of picoDB and go into more details about how you go about using it. And we're going to talk about some of the preliminary performance characteristics, and I want to emphasize the word preliminary because I'm still in the process of doing some additional testing with it, and some of the future plans I have for this particular tool. So let's go to the world of microcontrollers. I'm sure some of you are familiar with the world of microcontrollers, so for the next 3 slides, you guys can take a nap. I'm sure in case your lunch is a little heavy. But basically, in the microcontroller world, I think you can really narrow down a lot of what you do into 2 categories of actions. Called a grab type action, in other words, what people do with data acquisition systems, or the trigger action where you essentially are controlling something like a motor or a relay switch or such, or it could be a combination of both. So given that kind of environment, this is originally the kind of thing that we used to be using in the microcontroller world, just to give you a frame of reference in terms of the resources. So this is a venerable Intel 8051, a whole 4K of program memory, 126 bytes of RAM. This is the old version. And you can actually address 64K if you go outside of it. So it was very I/O intensive kind of processing. And despite that fact, the Intel 8051 proved to be a great workhorse in the industry. And what essentially was behind the software in things like the Intel 8051? Well, you essentially, to give you an example, in the data acquisition side, you have the ability to grab signal information that came in there, do some digitization process, and then do perhaps some additional conversion, and convert that into messages that are sent to a host, and the host did quite a bit of crunching in terms of analysis, decisions, so on and so forth. But what's been happening in the microcontroller world in the meantime, since the Intel 8051? Well, we're really grown up. This is an example of what's available in the market right now. It's something like the Atmel SAM4S. Have 160 KB of RAM, 2 megabytes of flash. Now, that may not seem to a lot of you. You can get to now 2 gigabytes inside a memory stick about this size. And so what's a big deal over here? To the people in the better world, it is a big deal. Usually, on an average, this kind of generation of machine would not have as much as flash as is shown over here. On average, it would be something like 512K of flash and probably something in the neighborhood of 64K or even 128K. But it's not unusual to find processors of this nature. And again, the same I/O functions that you find in microcontrollers throughout, whether it be serial or now even the access to the Ethernet, so you can go, a microcontroller can talk directly into the internet. That's the generation we're talking about. So what does that mean in terms of the kinds of software they can put inside these types of processors? Well, now we can, and we go again to the same example I had before. We'll talk about quote-unquote grabbing signals. We can do a lot more sophisticated conversion, and we'll call it more transformation, because now you have the capability to do some more complex algorithms in terms of how you essentially transform the data you grab into some meaningful patterns. And also beginning to have the capability to do some certain amount of decisions about what are you looking for. What does this thing look like? Is there a pattern around here? And essentially send succinct messages to somewhere in the cloud, wherever that is. It could be a server, it could be another host processor, whatever, that actually would make some additional decision as how to act on these patterns that were discovered by the processor. So now I'm going to focus a little more about decision, because decision here means something more than meets the eye. What we mean essentially is that you're gathering history of what exactly is happening in a process. And you essentially want to have a model that you want to apply to it, whether it be you're doing work in process control, in data analysis, whatever you want the application to do in your microcontroller. And essentially what the need is right now is to now think in terms of something that can organize and store that data, given the additional hardware resources that are beginning to come in some of these microcontrollers, to gather information on the history that went on, be it sensor trends, traces of certain activations, and use models that could be a bit more sophisticated. Some perhaps shallow rule sets, some perhaps some small decision trees, or maybe some other capabilities. And that's what got me, in particular in my case, I was essentially working in similar areas. And that's what got me thinking about, I think we need a consistent way to organize data at the microcontroller level, just as we have with larger processors. And just to the idea, when talking about processors, just to bring it back in here, we're talking something in the neighborhood of, like in this case illustration, like an ARM Cortex-M series family, if you're familiar with microcontrollers. I'm not talking about the R series or the A series. In other words, something that you put in a Raspberry Pi, because I consider that a lot more sophisticated than what I'm working with right now. Ergo, we went into picoDB. Just to give you an idea, picoDB is essentially the bare essentials when it comes to building a database. It essentially has two particular elements, something called the metadata universe, where you store information about what kinds of data you want to have organized, and the data store units, or dbverse, metaverse, and dbverse. There are multiple one table, and I mean table in the database sense, and not the eLua sense, of in-memory databases for now, initially, and because I'm waiting for a little more maturity in some of the file management packages being developed for eLua, and see how that really is going to go in the future. But for the moment being, I'm managing in-memory databases, so to speak. And just to get an idea what the API is for these databases, I'm going to go through a catalog of the functions that I'm implementing within picoDB. You have DB setup, which very simply says I have the database stored somewhere. It could be in Flash, and I want to bring it in. And basically what it does, it brings it in from a particular format and loads that database information into memory and returns a status code. Everything went okay. There was a little problem. DB commit, on the other hand, is the opposite. I want to store this stuff away and that database information, if I have the capability to put it into a file. DB commit is not quite complete at this point in time because, again, I'm waiting for more capability in eLua in terms of what can you store. Some things can be stored multiple times in Flash, or perhaps I'm going to use the SD card type interface in this case. But that's the idea behind that particular function. The other one, of course, is DB define. I got to define what are those databases. What would they contain? What is the metadata involved? And again, you return a status code to show whether that definition went through okay or there are problems. DB locate is very similar, if I go to the SQL world, to the select verb. In other words, I want to essentially extract a series of data tuples out of a database subject to a series of constraints. So either I get a list of matching tuples, this is kind of a table of tables, so to speak, in the eLua sense, or I return an error code. There was a particular problem associated with it. If I want to add or update a database, I will use a function like dbbuild, which allows me to add or change data tuples to a database subject to data attributes constraints. If I want to add one, I simply supply to it a particular series of a particular key that I want to store with, because it uses a key to sort of store that data, to essentially store the tuple into the database and return a status code as to how that operation went. I'll give you examples in a little while to see what that looks like. dbdelete just simply removes a particular chunk of data from the database subject to certain constraints on certain data attributes. I only want to remove this particular tuples, but not others. dberase, on the other hand, is more absolute. I totally want to remove that database from the metaverse and the dbverse, the metadata universe and the database universe, and return a status code saying how well things went. Finally, one thing I added, which is kind of perhaps a little unique, is I added a sorting capability, a limited one rather, to data tuples within the database based on at most 2 attributes at this point in time. And the database simply, we come out of that is a list of sorted tuples based on these particular 2 attributes from that database. Or, of course, if there's an error code, if something went wrong in that particular situation. Here's, we've got a few examples of how we use picoDB. You want to define essentially a database called MEAS, measure, and I essentially give you that definition as a table where I have a parameter name, which would be ID, followed by the type of the content of the data, which is string, and the other one, the other attribute for that particular database will be the parameter measure, which is a type of number. In other words, I can put a particular number. I'm not differentiating between floats, integers, and so on. Right now, I'm using essentially the embedded capabilities of Lua to do that. Or a table that, say, for example, contains a series of coefficients that you want to do, let's say, for an equation. And I would store it as saying by a row or a column, and by a row column designation. And essentially setting is what is a particular value of that particular coefficient. And how would I add, for example, data to that particular row? I use an example where in the third, the third line, we're using dbbuild to add into the measure database a particular row with an ID of A0 and a value of measure of 45.2. The key is that number 876. Again, where you have the key right now, if you want to do an update, you would say something, give me everything with whose measure value is, let's say, below 50, and I essentially want to update some information about that. In the same thing, in the next example of coefficient, again, the same situation. I'm adding a row to the coefficient database. And again, really simply think of this as essentially one table for which a series of tuples have been added. And the key for that particular table happens to be tempf, Fahrenheit temperature, and I have a setting. And the last one, you see an example of how I use dbsort. I want to use dbsort, and I want to sort it first by measure and then by ID. I want to essentially see everything that falls within a certain range, which records fell into within a certain range and value based on the IDs that I have collected so far. One thing that's very unique about, I think it's unique anyway, about picoDB is that one thing you want to do, and you do quite a bit of with a microcontroller, is send messages back and forth, let's say, to a device and essentially verify a reply from that particular device. So I added two functions in that particular API, one called dbMessage, which allow you to format a message based on a particular structure for a message exchange protocol. So it returns to you a hexadecimal string representing the message of the message. That's exactly what you will send to the device to get a response. If you want to give an example, I'm talking about over here. If you're familiar, if some of you in the better world are familiar with a Modbus protocol, essentially this will essentially create, let's say, a Modbus message. This would be essentially set a particular register, such as a digital register or an O4 message, which would become kind of a hold register, and essentially and get a response back from the or do a read for a hold register and get a response back from that particular device. dbVerify, on the other hand, takes the response back from the device that you've gotten and does some processing, and I talk about it a little more in more detail, to that particular message and returns a status code. So either everything went okay, or there's a particular problem that occurred. There are essentially two tables that are used to enable dbMessage and dbVerify. In the case of dbMessage, there's only one table. This I call protocols, and that is a reserved name basically for a table, in which I identify the protocol almost parameter by parameter. For each parameter, I give information as shown here of the type, which can be a string. And again, the type forms that I use is what's currently used in Lua. The range of the values that it can take, either it has a table in the Lua sense, which could be either a maximum or a minimum value if you're talking about continuous values, or a table of discrete values if you have an enumeration. And the default value you want to assign to that parameter should that you get no information regarding that parameter. The location is where in the message, what byte location in the message should that particular parameter be in, and what is the size of that particular portion of the message that the parameter occupies, how many bytes does it occupy. There is a provision here, and I'm going to go into details in here, that allows you to do things like, suppose you have a parameter whose size varies based on another parameter. There is a capability that I incorporated here as well in parmblock, which is essentially the location of that parameter. It tells you, in a sense, point back to this particular parameter to get information about how many of those you're going to have. and the size is the actual size of each individual parameter you have. Just say, for example, and I'm going to go back again to the Modbus protocol. Sometimes you have values that are added, let's say, to a Modbus message, which stands for what addresses what you want, what address range you want to get values from, or what values are returned back from a particular device. Protocol stores not only the request that you would send potentially to the device, but what is the structure of the responses coming back. So you know pretty much, we have essentially a way keeping some consistency, maintaining consistency about how you dialogue to that particular message. In the case of dbVerify, it also not only uses the the protocols table, it uses another one called Verifier, which essentially includes, it refers to a particular message ID in protocols and a particular param ID in a particular protocol, and essentially defines in a table kind of a process. Currently, right now, that consists of a kind of a stack machine structure, which is in the table, which does, in this example, shows a calculation. Here, essentially, doing calculation and converting Celsius to Fahrenheit. And the P underscore stands for, give me the current parameter value associated with the parameter I'm dealing with right now. And the last value, the rest essentially are in a sort of reverse notation, the formula for doing the calculation, and the last entry in that particular table, preceded by the equal sign, is something that I call a resource. It's sort of a variable within the context of picoDB, which you want to store, where you want to essentially store data concerning the process you're looking at or you're trying to control. Here's an example of how you combine dbVerify in a very, very simple loop that will retrieve things like humidity or temperature data from, say, a temperature or humidity sensor. You simply use dbMessage to build that particular message. If the type is not, if I return a type of the message which is not a string, then I know I have an error. And I was supposed to get a string back in here. I do some sort of conversion of that string. I send it out to the device itself. Perhaps do a little bit more massaging of my own, and essentially use dbVerify to get the response, to analyze that response, and either get a correct status, or let's say I get the response. I know what resources has been deposited in, retrieve that resource, and perhaps perform a little bit further analysis on it. And so it does some amount of reduction in terms of some of the logic that has to be added to the core algorithm that you may be running within that particular microcontroller. Currently, let me talk a little bit about ongoing work and emphasize ongoing on performance characteristics. The current platform I'm doing some of the testing on is the future-like ETSCM32 stamp. This is incorporates an ARM Cortex M3, and there's the Vital 66 on it, 64K of internal RAM, flash of 512 KB. Just giving you the other dimensions. I'm also looking into the Arduino Due, which I found a very, very interesting platform in this particular context. The issue there right now is that I don't at this point in time want to get involved in the conversion of the eLua, a body of eLua code into the Arduino Due. It's using the SAM4S platform. I've been kind of querying the eLua distribution list about, has there been an update of eLua? Is eLua now certified to work within the SAM4S platform, which is what runs the Arduino Due? I haven't gotten a response yet today. If anybody knows anything about it, let me know. But if push comes to shove, I'm essentially do the conversion myself, and we'll see what happens there. Just to give you an idea what results I've gotten so far, I took essentially a sample program not too unlike this one, which essentially does looping between verify and dbMessage and dbVerify invocations. I did not include the I/O sensors because I want to purely get the timing of the database access. So I have that particular chunk just simply generate some random values. We're using essentially a preset protocol and verified tables via eLua Build. And by eLua Builder, I took that particular chunk together with picoDB, the body of the picoDB, and compile it using the eLua Builder and the eLua website got an image about the size of 270K. Just to give you an idea of a reference, the right now, eLua footprint itself, as I understand it, has flash of 256 KB by itself, and it requires RAM of 64 KB, which is what I have in the ETM, at the ETM stamp 32. The preliminary results today that I have, and I think that bears verification. So I'm going to put a little bit of a caveat there. Is the particular chunk that I have in mind, together with picoDB, ran for about 1 millisecond per cycle. That is, per one particular cycle of that particular run that does that loop between the construction, the message, and verification of the response that I got back. But I need to do a little bit further testing to make sure that that is the case. And just to give you an idea where I want to take this particular package, I am bringing out a product first quarter of next year. My company is called, and that is me and myself right now, called picochain. I don't want to say more at this point in time. More will be said first quarter next year. But I am working on the idea of adding more development and deployment tools for eLua. If you want to, what I mean by that, for example, is let's go back to the bottom of this particular slide when I essentially create that stack machine structure for the processing formula. I want to have a way of just simply having a formula expressed in a more natural way, and have the tool just simply, because right now I have to sort of hand do this, hand code that in there, essentially do it have expressed the form in a more natural way, and have the tool converted into that stack structure as well. I'm sure there are tools out there that can do that very neatly if I want to do it offline, but that's something that I want to incorporate as part of the development and deployment tools. Also, the creation of any kind of tables that you want to define, and essentially assist in the creation of code that we use picoDB. But the thing I really am a little more excited about is that perhaps in the second quarter of next year, maybe earlier, I'd like to set up a SourceForge page for picoDB, and I like to start getting a community version of it going, because I like to increase participation from the Lua community and the community at large in trying to increase the capability of this particular database. I think this is, I think of this thing as a kind of diamond in the rough, so to speaking. I think there's more to me than meets the eye over here. Again, this is something I like to get the community in general to get involved in. One thing about myself in terms of my background in Lua, this is the first year I've been doing Lua, and I picked up on it rather quickly. I was, in terms of the product I mentioned over here, picochain, I was debating whether or not I should do this in C++, and then came Lua. And believe me, I was impressed with what Lua had to offer, particularly what eLua has incorporated in terms of I/O capability for a microcontroller chip. It is rather impressive with the ease of its use as well. So right now, with no further ado, I want to turn it to you people. And do you have any questions or anything to say? I appreciate it. Yes?
What's the memory structure for the database? So you keep it
in memory right now. It's memory. So it's... It's a series of tables. It's a series of tables, correct. It's a series of all tables, right? Yes?
Maybe I'm asking really stupid questions.
No, go ahead. No question is stupid with me. Go ahead.
So with these limitations on memory, usually microcontrollers do not have true operating systems.
They don't.
They not multitask, so they do only one thing at a time. So if microcontroller is talking over serial port or something, it's not doing anything else.
Right.
So if your microcontroller really controls something, and it's in a control loop, now you want to use your database to change the parameter.
Right.
How exactly do you want to do that?
Right now, basically, I'm restricting it to just a serial operation at this point. You pointed to having a capability to do sort of multitasking, right? Oh, yeah, so that switching, that may have to be incorporated into the logic right now. I don't have anything in the database itself to do that. It's part of the overall logic we have to do it with. So it's a matter of trying to mingle that with what the database does. I'm not too concerned about that right now, but if there is a need and there is a feeling in the community that this is something that ought to be added, by all means. You know, I'm open at this point in time. Yeah. Any other questions? Yes? Oh, okay.
Hello.
Yes.
So what are the plans for supporting like plain Lua? Because the thing, well, it looks like it would be very. Do you understand me?
You're going a little fast, but go ahead. All right.
Okay. Do you have plans for supporting plain Lua and not eLua?
Not right now. Not right now. I want to keep it within the embedded environment. eLua to me is the way I would like to go in my particular area. But again, this is going to have to be sort of community driven. If you feel that you want to push this in the Lua direction, then again, be my guest. That's my feeling. But that's where I'm at this point in time.
Right. Because I also see really tiny microcontrollers are getting improved and they're getting
much better. Correct.
But I also see that microprocessors get smaller, if you can understand me there. For example, you can get Raspberry Pi fine, but still there are also smaller processors than that have MMUs that can actually run Linux on 100 megahertz.
Yeah.
And there you got plain Lua. And
you wouldn't have the Raspberry Pi today if it wasn't for that.
Well, that could be the use case.
But yeah, that's a good point. That's a good point. I'm keeping things, and this is purely driven because of the way I'm dealing with my product, within the range of an ARM Cortex-M series type processor, which is more the microcontroller level. If things would change and say, hey, guess what? I can get the same capability inside something that fits within the footprint I'm thinking about, which is a rather tight footprint that does the same thing, say, for what the OMAP processor does, say, in something the size of a BeagleBone or a Raspberry. There's something that we think about in terms of migration, but I've seen that a little further down the pike right now for what I'm trying to do. But again, in terms of picoDB itself, if there is a interest once I put it out as a community version to push in that direction, I rather have the community driven. I think what I'm using over here in terms of picoDB is something akin to what MySQL did when they put out their version product. It is essentially a community product that somehow was spun off also with a commercial version, but the community version was kept. And at least that's the way direction I'm heading. I want to create a community relationship with picoDB. Okay. Open source type thing. Okay. Yes. Yeah.
I did something similar on a whole different sort of platform as part of some homebrew home automation system. I collected data from a bunch of temperature sensors and other environmental sensors, and I had all the stuff stored in an SQLite database. But along with each sensor definition, I had a string which just stored basically a Lua function definition that could be invoked when transforming the raw measurement into what I was going to store and process. And then when the system fired up, it simply, basically loaded all those functions and associated them with the sensor. And I just evaluated that function versus that stack-based approach. I'm kind of wondering why kind of take the detour into building a separate evaluation engine when you've got Lua hanging around that can do all that for you.
What do you mean by a separate evaluation engine? In what sense?
Well, rather than having this sort of stack machine approach, why not just put a Lua function definition there?
I hear what you're saying. That could be a possibility over there. The only reason I put this Lua stack machine in there is I thought that at the time I was very, very concerned about calling the Lua interpreter itself and the overhead that would invoke in the microcontroller at this point in time. I played a little conservative over there. If I found it later that the only thing I need to do over there is just put a function definition and just plop it in and you want to do it,
yeah, I think you could compile the essentially load the function once.
Right, I'll have to test that out on eLua and see what whether or not that it could take that overhead. Any other questions, comments? Okay. Well, thank you very much.